All right, good evening. Welcome into my channel, everyone. I am Professor L, and I am hosting this live stream for math engagement. I hope everyone's doing well, and yeah, I'll go ahead and get started. I am, again, erasing my board. I wish that I could go ahead and I guess I fell into a bad habit of not erasing it, and so now it's hard to erase before I click go live. I'm gonna try really hard to have these erased, but it's fine. I am gonna go ahead and get started talking and about this problem I picked out, and yeah, so it's kind of related to triangles in a way, but it's mainly involving circles. And it's an application that appeared in an example in a textbook I taught years ago, and I liked the problem, and so I went searching for one on the internet, and I just asked the Google chat for this problem and tried to find one that would be able to fit on the page, because I'm a limited board space, so I don't want to have to draw a graph that it's too hard to get the numbers like out to 100 or something like that. It's the scale to get it to fit on the page. So I'll go ahead and start. Let's go ahead and head it. This is an application for circles. So I'm going to label this circle application. And this is just one application. What this is called is triangulation. So we'll go ahead and put that in there, triangulation. Is popular in GPS. It's also popular in locating somebody's, like, the cellular data, any type of epicenter or anything that you want to locate. What they do is they use the coordinates of 3 localities, and then they use circles and radius or the diameters of circles, and they find an intersection. You can also solve this, I think, algebraically, which I'm going to graph it, and I'm also going to try to solve it algebraically. So without further ado, let me just get this. So you have these 3 equations for, well, actually, let's go ahead and write the equations. So it says there's station A. Ooh, that's a bad marker. Okay, station A. Might be time to get more markers out. And then you have station, so it's at 0, 0. It's located at 0, 0. That's a really bad one. I know I have a good marker out here. I just have to find it. And then station B. Go ahead and leave some room for station B here. This is a better one. Much better marker. Station B is at 8, 0. These are the centers. So we'll go ahead and list the center. And then we've got one more station down here. Let's leave some room for the equation. C is center at 4, 6. All right. So we're just trying to stay organized and yeah, just so we have this equation in standard form. We've got, we'll put it up here, standard form. And you've got x minus h quantity squared plus y minus k quantity squared equals r squared. And we have h comma k is the center and r is the radius. So we have our centers. It also gives us the radius. So it says distance 5. So it's saying the distance from station B is also 5. And it's saying this distance is from station C. So it's that'd be just distance of 3. Okay. So when you're writing your equations for your circles, so we can graph these based on this knowledge. So let's go ahead and sketch these circles out, and then we're going to write the equations. So we use this. All right. So I'm going to go ahead and I'm a pretty big graph. And I might have to get my ruler out. The reason is because when you're measuring these distances, you want to make sure graphic solution, you have to be pretty close to exact. So that first, so we've got the center at 0, 0. Let's go ahead and rotate these. Okay. All right, so we've got 0, 0 here with a distance of 5. All right. And 8 comes 0 with a distance of 5. So we should be able to go up. Oh. Let me get a different one, Scott. Okay, this one I like because it's got the net there on both sides, so I don't have to worry about it. Okay. All right. So we're going to go out a distance of 5 from that center. We'll say 1, 2, 3, 4, 5. We're going to go out a distance of 5 here. 1, 2, 3, 4. We'll do a couple more. 10. Okay. All right. And then we're going to go out the same here. We can go up 10. I think that that's pretty even there. Okay. So we're going to go out 5. 1, 2, 3, 4, 5. All right, and then we're just going to draw our radiuses in because these are actual locations on the graph. We've got these points that exist. Okay. So I can go ahead and sketch this circle pretty accurately. Got that first one, station 3. It's within a 5-mile radius. So that next center is at 8, 0. So let's see, 5, 6, 7, 8. So I've got this center right here. And we have a distance of 5 as well. So we're going to go up. Let's see. And just to kind of get it exact as possible here, right there. And then find out from here. A little bit further down. And looks like we need to go out a little bit further than 10. So we'll make this a little bit longer. Okay, 8, see, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5. We'll go one more out, 14. So we've got this point here on there. And then from here, we've got 1, 2, 3, 4, 5. This one as well for that circle. So all I'm doing is I'm locating that center and I'm going out the distance from the center, 1, 2, 3, 4, 5, and making that be my radius. So it looks like we got the same size circles here. Let's see if we can just sketch this one here quick, pretty accurately. Okay, that's not too bad. So we've got an overlap and an intersection here. So what we're doing is we're locating where all 3 of these circles intersect. There should be only one location for that. To get exact, either use a graphing feature like Desmos, or you would use graph paper and sketch it out by hand. But I was thinking that I could get close here, so we're just going to try. And then what we're doing is we're solving this system. We're looking for a unique solution that satisfies all 3 equations. So we haven't written those equations yet. You would need to write the equations in order to solve it algebraically, which I'm going to attempt to do tonight after I'm finished graphing. So we've got a center for the station 3. So you can see we've got at 4, 6. So with a distance of 3. So I'm going to go out here 4 and go up 6, and it looks like this is my center for my 3rd circle right here, 4, 6. And I have a distance of 3, so I'm going to go out 3 from that 1, 2, 3. It's going to put me at 1, 6. And then 1, 2, 3. That's going to put me at 7, 6. And then going down 3, 1, 2, 3. That's at 4, 3 right here. Wait. Yeah, 4, 3 is on there. And then we have C sign is also on there. All right, so we have this circle. See if we can draw it in here accurately. And it looks like I have my triangulation coordinate right here at 4,3. So if you can see where all three of those circles intersect is only at this one point. So it looks like graphically it's at 4,3 for my solution. And then what we can do is we can go and turn around and verify. Almost tripped over a cord. Okay. Setting that ruler down. All right, so looks like we graphically looked at the solution, but let's go ahead and write the equations and see if we can just solve it really quickly algebraically. So we have this first one, and so we're just using the standard form for this equation, and we're going to insert values based on the center at h comma k. So we'll go with that in here. Is that h comma k? Okay. And then r is the radius. So in this case, this would be r. So we're going to write our equation. We'll say x minus 0 y squared plus y minus 0 y squared, and that equals r squared. So that's going to be 5 squared. And so when you simplify this and expand those parentheses, you just get x squared plus y squared equals 25. And I want to box that because we're going to come over here to the space here and see if we can't use it to solve. All right, and then this one here, we're going to repeat that process, h comma k, and you have r. So we're going to say x minus 8 y squared plus y minus 0 y squared, and that equals 5 squared. And then we'll simplify this a little bit, and we can say x minus 8 y squared plus y squared equals 25. And let's go ahead and box that. And then this one down here, let me see if I can. I really kind of wasted space here. So I'm going to move this up. I really want to fit all three of these on here. And, yeah. So we've got the center at 4,6, and we have x minus 4 quantity squared plus y minus 6 quantity squared equals 3 squared. So really all we have to do is just change this to a line to simplify. And we have these three equations. I could expand this and put it in general form, trying to figure out what the best thing to do would be. Okay, so this one is already in general form. I don't have to worry about it, but this one I'm going to try to expand it out a little bit more. So I'm going to figure out what x minus 8 quantity squared is. And that is just x minus 8 times x minus 8. So we'll have x squared minus 16x plus 64, it looks like. Right. So I can rewrite this one. We'll say x squared minus 16x plus 64 plus y squared equals 25. And then, so I've got this one, let's see if we can do this one as well. So let's see. We've got x minus 4 y squared, and we have y minus 6 y squared. And that equals 9. So we'll start with this one. This is going to be x minus 4 times x minus 4, which is x squared minus 8x plus 16. And then this one is going to be saying y minus 6 times y minus 6. So that's going to be y squared minus 12y plus 36. And that equals 9. All right, so since I have all 3 of these, can I somehow, all right, let's go ahead and combine these constants here and get this a little bit simpler. So this is going to be x squared minus 8x plus y squared minus 12y. And that is going to equal, let's see, 16 plus 36. So that's 42, 52. Oh, it's going to be negative here. Let me just calculate. And see. All right, I'm getting negative 43. I just want to make sure. All right, so I have those, and can I somehow, let's see if we can do it. We've got these 3 equations, so we have a system here. So we've got x squared plus y squared equal 25. We have x squared minus 16x plus 64. Oops. Let's go ahead and we got to combine those constants. This is y squared equals 64 minus 25. That's 39, negative 39. All right. So we've got x squared minus 16x plus y squared equals 39 for this one. All right. And then that third one is this one here. We've got x squared minus 8x plus y squared minus 12y equal negative 43. All right. It looks like we have x's and y's. So we might be able to solve for it this way. If let's see, I want to be able to eliminate 2. So we got to figure out what, so we have x and y here. So I want to be able to eliminate at least the y's so that I can have, I could just end up with a quadratic somehow. So let's go ahead and add the equations together to see what happens. I'm going to start with these. See the ones that have, so these 2 right here. If I can eliminate x and y, I can get 16x equals something. So I'm going to add these 2 equations, just these 2. See what happens. All right, so I've got, we're not going to add them. What we're going to do is we'll manipulate. We'll say multiply the first one by a -1. So we'll say -1 times x squared plus y squared equals 25. And it's going to be negative x squared negative y squared equals -25. And then I'm just going to add it to the second one. So I'll say x squared minus 16x plus y squared equals -39. Add them together. So your x squareds will cancel, your y squareds will cancel, you'll get -16x. And we're going to add those together. 25 plus 39. What is 25 plus 39? 64. I think that goes evenly. -64. Divided by -16. It's probably 4. Yeah. So we've got that. Good. So we solve for x. X equals 4. Excelente. All right. I like that. Because now all I have to do is go, since I have what x equals, I believe I can go ahead and just pick one of those equations and plug in to figure out what y is. So I'm just going to pick the simple one, the first one, x squared plus y squared equals 25, and plug in for x and see if we can't get y. All right, so we've got x squared plus y squared equals 25, and we'll just plug it in. So when x is 4, we've got 4 squared plus y squared equals 25. And then 4 squared is 16. And I've got 25. So I'm going to subtract 16 from both sides. I'm going to get y squared equals whatever 25 minus 16 is. I think it's 9. Okay, it is 9. All right. So we'll just take the square root of both sides. You get y equals approximately plus or minus 3. And since we're looking for a coordinate, hang on. It gave me 2 for y, so let me check this out. It says y is 3. To 3, or y is -3. It's on there as well. Okay, so that's also a point on the graph. So it located those 2 points. Cool. Because it was the circle that was on the original one on the origin. So what we're doing is we found the solution algebraically. We verified graphically that it is at 4 positive 3. So we're just going to take the positive root here, and then what you would do at this point after you figured this out algebraically, 4, 6, you would want to either verify it graphically. So you'd verify it graphically, or you would make sure you would go back to your original equations and plug in. You're going to plug in 4 for x and 3 for y and see if you get true statements. So if we could just kind of like orally do it, x squared, so that'd be 16, and y squared would be 9. 16 plus 9 does equal 25. And then that one would be the easiest one to verify, but this one you could also do, you would say 4 minus 8 is -4 squared, which is positive 16. And then 3 squared, that also equals 25. So you're just seeing if you're plugging in your values for x and y, and you're just verifying and seeing if you get true statements in all three of your equations. You'd also have to do it here as well. It's one unique solution for all three equations. So you must be able to plug in that solution, and it should give you true statements in all three of your equations if you've actually found the right solution. And that's kind of a way that you would just verify. Okay, right. Well, I was trying to get off the subject of the triangle application problems because I felt like I was stuck on it for a while. And then this afternoon, when I was trying to plan the live stream and pick out a problem for tonight, I found myself looking at those oblique triangles again. And yeah, so they're fun and it's easy to do, get caught up on for a while. But I was hoping that, and I've got to thinking, well, this is involving triangles, because essentially what you're doing is you're finding that you're triangulating. Let's go ahead and just draw the triangle here if you want to see it. What you're doing is you're taking these, you're making a triangle out of these, the centers of those circles. And then that point in the center happens to be the center of your triangle. It's pretty fascinating. So that's why it's called triangulation. And so although it wasn't exactly a triangle problem, that's how this problem gets its names. It's involving circles. So and it's pretty neat how you can get the centers to be the vertices of your triangles. And yeah. All right. So I've managed to talk about 30 minutes on this problem, and I think that that's probably sufficient. So I hope everyone is having an amazing Friday evening. And if you watch my video, I greatly appreciate it. And I hope that it helps. More importantly, just don't want to be up here in vain. But yeah, I will go ahead and end the stream for now, since I don't have any more questions from students. And I will just, yeah, I will pick it up again on Monday. So I hope you have an amazing weekend, and I will say bye for now. See you next time.